This technology and innovation event, VivaTech, starts today in Paris. So if you happen to be planning to attend, I highly recommend that you visit the Amazon booth.
Yeah, I'm sure they'd be delighted to welcome you and talk you through the technology.
I think they really would. One of the key people behind Amazon LEO's growing constellation of low Earth orbit satellites is the Vice President of Amazon LEO Business and Product, Chris Webber. Chris has been chatting with Arianespace's Aaron Lewis. Over to Chris and Aaron now, just to earwig a little bit on their conversation and find out more about Amazon LEO.
Hi, I'm Aaron Lewis, Vice President for Media and Government Relations for Arianespace here in Washington, D.C. And I'm with Chris Webber of Amazon LEO. Chris, tell me what you do at Amazon LEO.
Yeah, first of all, it's great to be here with you, Aaron. So I really appreciate it. I run the product side, the operations side, and then sales and marketing, the go-to-marketing side for Amazon LEO across our three segments, the consumer segment, the business segment, and the government segment.
You do it all, and that's incredible. Tell me what differentiates these products that you're developing from what exists in the marketplace at the moment.
Yeah, we're really excited to get service to market across those three customer segments. And I think there's three or four areas that I would talk about. First of all, just on the innovation side, and I'd start with performance, and we've talked about this. We'll have industry-leading performance. We'll be able to deliver over a gigabit on the downlink and over 400 megabits on the uplink. And so that is industry-leading performance at those speeds. The second thing I would talk about is just the value side of things. And that's, how do we think about the performance and price and doing it the Amazonian way and delivering incredible value to our customers, all those customer segments. The third thing on the innovation side, I would say we've really put a lot of innovation on the antennas, the customer antennas.
Yeah.
Our Ultra antenna on the high end, which primarily would be used for government and business customers, is what allows us to deliver that gigabit on the downlink, 400 megabits on the uplink, full duplex. That is industry leading. And then we will have the smallest LEO antenna that's ever been made. It's 7 inches by 7 inches. We call that our nano antenna. Again, it would be incredible for portability, mobility, those type things. So tons of innovation there. And then as you look at on the business and government side, the security that we've woven throughout the network, the encryption, allowing private networking, where you as a customer can select and take your data from the antenna to the satellite into your own AWS data estate or your own data center without ever touching the internet and not requiring a VPN. We're really getting a lot of positive signals. That comes in the forms of we're signing deals, we're announcing that we've announced deals with Delta Airlines, DP World Tour, Vanu, Vodafone, NBN in Australia. So we're really excited about the differentiation we can bring those three customer segments, and we're getting great signal and feedback from our customers as we're going to market.
Yeah, life-altering things.
Absolutely.
For the better.
That's right.
Well, this launch is happening from European soil on a European launch vehicle, the Ariane 6. What does this signal for opportunities that you are looking at in Europe for Amazon LEO?
First of all, I have to say, you have been a fantastic partner.
Thank you.
The other thing I would say is we're building this global network and constellation. And I would say Europe, in particular, your company, is contributing significantly to that. So I look at this as this global constellation. This is really about European innovation, European engineering, and European ambition, and contributing in a massive way to building this global constellation.
And on this launch, we're going to be delivering 36 Amazon LEO, the most Amazon LEO satellites that we've had on Ariane 6.
Very exciting.
To date. What does this mean for the deployment of the constellation?
Yeah, it's huge for us. I mean, that'll get us over 360 satellites in orbit. One of the things that we've talked about is we're going to start launching our service in the coming months. And this launch is critical to get us there, as is the other 15 that we'll have with you as well. But the exciting thing for us is, we have hundreds of customer terminals already being tested internally through employees. We'll start to work with government and enterprise companies, and then we'll start to launch service, what we said, in the coming months. And so this launch is critical to that. And so everything we're doing is now testing the network, starting to, what I would call it is just broad acceleration on the network side, our customer terminals, manufacturing those at scale, building our commerce systems, et cetera. And so everything that we're doing now is accelerating as we launch that service. We're really excited about that. This one's critical for us. We'll get that service in market and then just continue to expand from there.
Wow, that was fantastic. Well, it was very illuminating, and it was a pleasure to talk to you about this today, Chris. Thank you.
Thanks so much, and appreciate the partnership.
Yeah, absolutely.
So let's turn our attention now to our new boosters, which are allowing us to carry those extra Amazon LEO satellites.
Yes, and they're truly a great demonstration of European industrial expertise involving a lot of companies in Europe. And the P160 booster is developed by Europropulsion, which is a joint venture between Avio in Italy and Ariane Group of France. It's been developed for the European Space Agency.
Let's hear from the European Space Agency now.
Today, with these 4 P160Cs on board, Ariane 6 and Europe are going bigger, stronger, and further than ever before. With its predecessor, the P120C, we already developed the most powerful monolithic composite solid rocket boosters in the world. And today, we are reaching a new step. In the future, they will bring as well additional performance to Vega C. This is a true European realization, reflecting a broad collaboration across the European Space Agency member states. This is also a new step in the 40 years of remarkable history of solid propulsion in Europe, built in particular thanks to the French and Italian major industrialists, Ariane Group and Avio, together with their joint venture Europropulsion and Regulus. But the P160C is a larger European realization. It includes Belgium through SAPCA and Thales Alenia Space, Spain through Airbus Defence and Space, Germany with MTA, and Norway through NAMO. You see, this program truly embodies the European Space Agency spirit of cooperation, bringing together expertise, industrial know-how, and shared ambition across Europe. This means we, as Europeans, can go further and do more, support missions to the moon, reach destinations such as Lagrange points for missions like Envision, launch the second generation of Galileo satellites. In a few months from now, we will launch the Plateau mission for the European Space Agency science program, with the objective to find exoplanets. As you see, this is a real step forward. It strengthens both Ariane 6 and Vega C. It gives Europe a more flexible and capable launcher family. The objective is clear: to ensure that Europe remains competitive, autonomous, and ready for the future of space transportation.
So you can see how important those boosters are for all kinds of missions. Let's dig into a little bit of detail about them now. And joining me to do that is André Lafont. André is the program manager for the Ariane 6 boosters. So you're absolutely the right man for the job to tell us all about them, André. Thank you very much for being with us. Let's start with why. Why did we need a new booster?
So for 2020, the need for large constellation in low orbit clearly highlights the fact that Ariane 6 will need more performance. So we studied the different options for this increase, and one of the most quickest and effective solution was to increase the solid rocket motors, in fact. We identified, of course, other solutions, improvements we are working on now, and they will be implemented in the next evolution of the launcher. So with this first increase, this first step, we increase the performance from 10 to 15% in low orbit, depending on the mission. And as you already said, that means that in practical terms, we will launch 36 Amazon LEO satellites today instead of 32 in the two previous missions.
And how did you give them that extra power?
We just had to 14 tons of propellant on each booster. That means that now the weight of the propellant of each booster is 156 tons. And to do so, of course, we had to add one more meter on the motor case of the engine, but we reduced also the forward skirt of the booster for 1 meter to keep the same length of the booster, 22 meters, and also to keep exactly the same interfaces with the central core of the launcher. So that means that all the assembly of the launcher on the pad is exactly the same than previously.
And it must have been a huge team effort getting them ready in time.
Yes, of course. So we worked with our main partners on this project. So it was MTA, Airbus Spain, and of course Avio and our joint subsidiaries, Regulus and Europropulsion. And certainly the major step of this development was the static firing test of the first P160C. We had in April 25 in Kourou at the BEAP, so the large test bench operated by CNES, in fact. So yes, we worked hard together, and with the support of ESA, of course, and we achieved to qualify this new booster and the launcher with this new configuration in less than 4 years.
And did you have to change how you actually manufacture the boosters?
Yes, of course. So we have to adapt all our supply chain on main production means in all the partners. And also in Kourou, with the assembly line, we have to upgrade in Europropulsion, but also on the ArianeGroup building to be able to produce these new boosters. And CNES also had to requalify the transportation of this heavier booster on the Fardier, so the extra large truck we have in Kourou, and which allow to move boosters between buildings and up to the ZL. So I think now all is ready for flight. So I think we are all excited to see our new booster flying.
You must be, after all that hard work. Well, listen, very best wishes to you for the launch. André, thank you very much indeed.
Thank you, Katie.
So we are on the northeastern coast of South America, the Amazonian coast of South America. We've had the latest weather check. You can see the skies are very blue and very beautiful. It was raining yesterday, but today we seem to be lucky with the weather in terms of the camera views, hoping to get some really nice shots of our launch today. But of course, rain isn't a problem, is it, Loic, for us if it's raining? And it does rain a lot here in the Amazon rainforest, but
it does, yes.
There are other things we need to monitor.
The rain is not an issue, but we need to monitor two main things. First of all, the wind, and in terms of speed and direction, mostly for safety reasons. We control these winds, and of course the storms, the lightning strikes, the lightning hazard. Right now, the launch pad is protected by 4 metallic towers that you can see around the rocket, so it's safe. But once we are up in the skies, of course, we don't want to be struck by any kind of lightning that would damage the electronic equipment. So.
And how do you monitor the weather? What systems do you use?
So we do have a full weather station in Kourou with a staff that is in charge of checking several times during the preparation of the launch the weather forecast. To do so, they are using balloons that they inflate. They, of course, are equipped with a lot of sensors. So they send these balloons into the sky and they report precious parameters like temperature, humidity, and wind speed, and so on.
Getting some nice shots there of the weather centre, and very, very important work that they do there. So the teams have been working here at the Guiana Space Centre for, a couple of months now, preparing the rocket and the satellites for today's launch. We call this whole process the launch campaign. And it's a very, very important process with teams, of course, living on site, and no doubt a lot of camaraderie. Our cameras have been following some of the main events during the launch campaign, Loic. Why don't you talk us through what people have been doing?
Sure. First of all, the 36 Amazon LEO satellites have arrived to French Guiana about 2 months ago. They were transported to the Space Center and prepared in their own facilities. And a month ago, the main elements of the launcher Ariane 6 have arrived by boat to French Guiana. They have been transported from the port of Paracabo to the Space Center. You can see here the 2 main stages being exited from their containers. So you got the lower stage and the upper stage. The first great step of the assembly of the launcher, of course, is to assemble these 2 stages together. It is realized by the teams of ArianeGroup. It's a very precise operations. You can see that it is done horizontally. And once these two stages are assembled, they constitute what we call the central core of the rocket. It is then transferred to the launch pad, to the mobile gantry, this very big building that you see, which is hosting the rocket during its final assembly. The mobile gantry is a very huge building, higher than the Statue of Liberty and heavier than the Eiffel Tower. So it's a massive building to retract from the launcher once we are in the final chronology. The solid rocket boosters, the 4 of them, are prepared separately in a safe zone in the launch center, and then they are accommodated along the main core of the rocket. Of course, once we have this assembly performed, we have the last great step of the mission, which is the arrival of the satellites. They have been prepared, as I said, separately in facilities dedicated to them, and then encapsulated, as we say, inside the fairing. And the whole thing is transported to the launch pad area. And then, of course, the fairing is put on top of the central core. It marks, of course, the last great step of the assembly of the Ariane 6 launcher. A lot of checks and final things are settled after that, but we have now Ariane 6 ready for launch, and the heaviest launcher ever launched from French Guiana today.
Yes, indeed, quite a record. The heaviest launcher with the most powerful boosters also launched from
yes,
here.
Indeed.
Yeah, so there they are on the pad, waiting, the satellites inside the rocket, waiting to start their ride. And all eyes in the control rooms on these boards. These are the status panels. They're showing us the live go, no-go status of all the systems across the base.
Yes, it's a synthesis of the parameters of the launcher, the launch base, and the satellites. So everything is green, means that we have the green light for
À
launch.
12 DDO, attention pour la séquence finale, lanceur. Top, à 0, moins 5 minutes.
So our range operations manager, Axel Serg, has announced the beginning of the synchronized sequence. This is an important milestone. It's the last 5 minutes of the countdown. We often call it the automated sequence as well. Everybody across the base, of course, will be listening out for Axel's voice throughout today's launch. Right, lots of very important operations happening now, aren't there?
Yes, it's basically the final race for the preparation to lift off. Right now, we have many operations going on. The computers are taking the lead over the humans. We are activating valves, checking pressures, activating currents, avionic equipment, and of course also monitoring very closely the safety aspects. So these 5 last minutes are really the final preparation, and it's getting the launcher autonomous step by step.
You can see there that the spaceport is a big place. Nice shot there of the engine on the main stage, the Vulcan engine. It's a big place, lots of facilities, several different launch zones. We've got satellite preparation buildings, offices. We call the whole thing the range, and we have a couple of important control rooms here at the spaceport on the job today. We've been looking at mission control. Of course, the other one is launch control. What are they doing in there, Loïc?
So in the launch control room, you have all the teams that are in charge of the operations. They've been working for many hours now. They are located 5 kilometers from the launch pad, so pretty close from the pad, and they are in the reinforced concrete building that protects them, of course, from the blast of the launch. They've been doing the commands for filling the tanks, pressurizing the system, do all the planned checks for the launcher to get ready. And all these engineering teams are monitoring all the parameters right now, temperature, pressure, electrical currents, and so on. And they are backed by a support at the Space Code in France. So we have extra brains in the headquarters of Ariane Group to help if it is needed, of course, in case of any mishap just during this last sequence.
Indeed, and laser focus now for everybody in all of these control rooms. Nice shot of the pad there. We can see the lightning towers, and on the right-hand side right and left of your screen, you can just see the concrete structures. Those are the flame trenches there. Great shot of that flame trench. It's where the fumes will come out at liftoff. And then 3/4 of the way up, those yellow structures are the cryogenic arms, and they're clamping onto the rocket, and they're feeding very, very cold propellant in.
Absolutely. We are using cryogenic oxygen and hydrogen as propellant for the lower and upper stage. So liquid hydrogen is minus 253 degrees Celsius, liquid oxygen minus 180 degrees Celsius. So very, very cold. And we fill up the tanks until 3 minutes before the launch. Of course, at the time of liftoff, the yellow arms will retract and will leave the way for the launcher to ascend.
So you can watch out for those. You'll also see the umbilical lines disconnecting and pulling away as well at the moment of launch. And you can also count to 7 when you see the first ignition, because we switch on the Vulcan engine on the main stage before the boosters, don't we?
Absolutely. 7 seconds, as you said, before the ignition of the boosters, we have a verification on the Vulcan engine, making sure that it works perfectly, because once we ignite the 4 boosters, there's no way to hold back the launcher. So we want to get ready for every system at the liftoff time.
À tous de DDO, attention pour moins 1 minute. À tous de DDO. Arrêt du temps des comptes suite à un rouge. Ensemble de lancement. Que tous les moyens restent prêts pour la reprise de la chronologie. À Giro, moins 5 minutes.
Okay, so he has just announced that he is stopping the countdown.
Indeed, yes, we had what we call a red. So here it's the launch range and launch base that is saying that something is not nominal as a parameter. So we are holding the countdown right now, and we'll stay tuned to the launch operation manager to know when we can retarget another liftoff time. We have a launch window today, meaning that we have a few minutes, about 29 minutes today to perform the launch, so we can solve any very minor mishap if needed.
And you can see the status panels on the left-hand side of your screen there, the red status panels at the top. Ensemble de lancement means the launch base, or the range.
Yes.
I believe. So what we'll do now is we will cut our microphones and come off air just briefly and come back to you when we get some more information.